Now you know sec x, cosec x and cot x, we're going to look at differentiating your trig functions. You need to know sin x and cos x off by heart now. They're not in the formula sheet. However, we're going to explore the new derivatives. They will be given in your formula sheet. Remember that cos x starts with a c, it's 1 over the s. Sec starts with the s, it's 1 over the c. And cot has the t, it's 1 over tan. If I ask you to differentiate tan x, we've already actually done this, then what you would have done is write tan x as sine over cos. That means you can use the quotient rule, so you have sine x, which will go to cos x, and cos will go to minus sine. The next thing is you have u dash v minus ub dashed over v squared, so you'll have cos squared x minus sine squared x over cos squared x. You might remember we've done this before. 1 over cos squared x, because you know cos squared and sine squared make 1, but this time instead of writing that as 1 over cos squared, which we left it as before, 1 over cos, if it's c at the bottom, it goes to the s, is the same as sec squared x. So now you have found the derivative of tan x is called sec squared x. The next one we're going to look at is 1 over tan x. How would you cope with 1 over tan x? Well, 1 over tan x is the same as 1 over sine over cos x. And remember, the cos will flip up. So it's cos x over sine x. So 1 over tan x is cos over sine. And again, we'll use the quotient rule. So you have u as cos and v as sine. The derivative of cos is minus sine. So just watch your signs here. You'll have minus sine squared x minus cos squared x all over sine squared x. Sine x all squared is the same as sine squared x. Pull out the common factor of minus 1, and then you get sine squared plus cos squared again, which goes to 1. So this time it's minus 1 over sine squared x, and if it's sine at the bottom, it goes to cos x, so it's minus cos x squared. So that is you found the derivative of 1 over tan. In the same way, cosec x, this time you have to understand cosec x has to be written as 1 over sine for us at this point in time, which can be wrote as sine x to the minus 1. You can use the quotient rule, but you don't have to. You could just use the chain rule. Bring the minus 1 down, and then it goes to minus 2. But remember the chain rule, sine goes to cos. Then we can bring the negative index downstairs, so it's minus cos over sine squared x. Let's split that up, so it's minus cos over sine x times 1 over sine x. And remember, this is tan inverted, so it's minus cot cos x. Doesn't matter whether you write the minus cot first or the cos x. It's like that in the formula sheet, so I've just switched it around. Tan x is sine over cos. In that case, 1 over tan x is 1 over sine over cos. The cos flips upstairs, so 1 over tan x is cos over sine, which is the same as cot. So remember that if you know that 1 over tan is the same as cot, if you know tan is sine over cos, the inverted cot is cos over sine. You can do it in stages, or you can just understand that it's the opposites or the inverted, okay? Sec x. Sec x starts with an s, so it's 1 over cos, so I'll do the same idea. That's 1 over cos, which is cos to the minus 1, minus cos x to the minus 2, and the derivative brings out minus sine. Minus and minus turns to plus, sine over cos squared x, and then do the same thing again, sine over cos times 1 over cos. That is tan times sec x. Okay. Cot. We've actually done this already, if you think about it. Cot is the same as 1 over tan, which is 1 over sine over cos, which is cos over sine. So then we can use the chain rule and do minus sine squared minus cos squared, and then pull out the minus. This is the exact same as one we have done before, because I asked you to do 1 over tan, do you remember before? It's just to show you that you will probably be given the cot. The good news is these are given in your formula sheet. So this is what the formula sheets will have information-wise, which means that you know you can go to it now, as opposed to have to use the quotient rule each time. But if you ever lose the formula sheet or you forget, you can use the quotient rule. You might then be asked to do something with two of the functions like cot x and sec x. if you can, manipulate them first because it's much easier. So let's go for, you don't need the product rule here. If you use cot x and sec x, cot x is the same as 1 over tan, sec is the same as 1 over cos. Well, in that case, that is the same as 1 over sine over cos, which flips up, doesn't it, to cos over sine. The coses cancel, you see, and then you've got 1 over sine, which you can write as sine x to the minus 1, and you could go ahead and differentiate. Okay? Or you could use the product rule at that point in time, but that makes it much easier. Okay. In the good old days, not that long ago, there was no formula sheet given. So the new trig derivatives were hard. You've got so many formula that we went ahead and used the quotient rule because we couldn't remember all the formula off by heart. But now you can use it. So I'm going to go to the old-fashioned way and now show you how to use a formula sheet. So tan is the same as sine over cos. So if I write it as sine over cos, then you would have sine 3x, but you'd have to remember the chain rule, wouldn't you? So it'd go to 3 cos 3x, and what's your sign for cos? U dash v minus uv dash is 3 cos squared 3x minus 3 sine squared 3x turns to plus over uv squared. You can pull out the 3 and you have cos squared plus sine squared again. As long as these are the same, it's still cos squared plus sine squared, so you have 3 over cos squared. That is the same as sec squared, so you have 3 sec squared x. Okay. Another rule that can develop from this is if you split it. So from that stage there that we have just did u dash v minus uv dash over v squared, if I split it, so it's 3 cos squared 3x over cos squared 3x and sine squared over the cos squared separately, then you'll see they go down to 1, which is 3, and these go down to tan squared. So that is 3 tan squared 3x, which has a common factor of 3. Now, if I go to the previous answer, then that is 3 sec squared. It means that your 3 sec squared 3x is equal to this. If I divide both by 3, then you get to that. And in fact, if I just ignore the 3x and put any variable there, you've got a new rule. It's a new rule, sec squared is equal to 1 plus tan squared. Okay? So you'll see that appear as well. If we use the formula sheet, it's much easier now, however. So if I go to y equals tan 3x, then we will look at tan. So you'll go to your formula sheet and you'll find tan, and you'll see that it goes to sec squared. So all you'll say is tan goes to sec squared, so I'll go sec squared 3x, but remember the chain rule and then just bring it to the front. How easier is that? Sine goes to cos if you have 2x, remember the chain rule, so I'm just using a few more examples to remind you. So if it was sec 2x, I'd go to sec on the formula sheet, sec goes to tan sec. So that means that if I was differentiating, I'd expect tan sec, but it's not x, it's 2x, so a 2 will go there and there, but the chain rule will bring out the 2 as well. So just be aware of remembering your chain rule. Sec squared 3x is the same as sec 3x all squared. So if we go here, you'll see that you've got your sec there. So we have, sorry, that should have been there. Okay, if we have 2 comes down to the front to the 1, but then the chain rule will bring out the sec derivative, which is tan sec. So then we'll get that to the side. So we'll get tan sec as a chain rule, and then the 3 as well. So then you end up with 2 times 3 is 6, 6 times sec is sec squared, and tan x. Doesn't matter to me which one comes first there, but I put the 6 to the front. Okay, I don't need an extra bracket in there, I've just got bracket happy. I can be really silly and even put a smiley face. So for cos x, it doesn't matter whether it's a 2, a 4, a 7, whatever, just to remind you about the chain rule. So if we go to the derivatives, cos x goes to cos x cot. So we go to cos x cot, but remember that whatever is here comes out as the chain rule. And all you would do is bring it to the front. Silly as it is, it's just to remind you about the chain rule. Okay, you have 2 tasks now. They're exercise 9 on page 67 and questions from Maths in Action. And they're all in the PDF, so you don't have to use this video. What I want you to do now is try page 24 and 25 of your PDF, and then you'll find these questions, for you to try using all your trig functions. And then in the Scholar exercise 9, you'll find the answers for Scholar in 2, 4, 7, 8, and the maths and actions are after this slide on your PDF. So you have all questions 30 to 39 in exercise 9, but remember you've already, or you should have already done 30, 31 and 32. So there's your questions and those ones. Okay, on you go.